Let's begin with Kubernetes today. So Kubernetes is a container orchestrated tool. Again, it helps in managing, maintaining our containers. Okay, this provides high availability for the containers. Again, scaling the containers. It has got auto scaling feature as well. Scaling, load balancing the containers on the cluster, rolling updates, rollbacks, and it also helps in recovery and backup. Right, all of these are container orchestration or container management. So how this does, again, Kubernetes manages containers on a group of Docker hosts. So what are those Docker hosts? How are the containers being on these Docker hosts? Let's see. See, again, we can create a cluster of any number, means cluster having any number of nodes. Out of all these nodes, one node will be acting as a master node. Okay, and the other nodes will be called as minions. Some time back they were called minions. Okay, some time back they were called minions, but now they were called as worker nodes or else simply called as Kubernetes nodes. Okay, you may call them as Kubernetes worker nodes or else you may call them as Kubernetes nodes. Okay, so this is how the nodes, a cluster is formed. And here, we'll get into more details or in depth to this Kubernetes architecture. Before going to Kubernetes architecture, I believe the rest of the things are clear for you, right? What is meant by container orchestration and all. We'll look into those with a hands-on. First, let's get into the architecture of Kubernetes. So here, if you look into this, Kubernetes architecture. Yeah, Kubernetes master, worker node, and worker node 2. You have got all these three nodes. And if you look into this control plane, so this control plane is nothing but the master node. Master node is called as a control plane or the decision maker of the entire cluster. Okay, there are again many other components in the master node. Okay, everything like a decision of deploying a container, everything will be taken care by this master node. But before going into the master node, let's start with the worker node. Okay, if you look into this worker node, here you can see again different components like Docker, Kubelet, Proxy, and pods. Let us look into these components. Every worker node will have these components. See here, worker node 2 also has got Docker, Kubelet, Proxy, pods, and so on. So first, let's with our components on a worker node. So let's start with first one, which is Docker. So what is this Docker? See, on every worker node, we are running a container. Means definitely container runtime should be available, which is Docker. Okay, Docker should be available on each and every node where we run the containers. And here we were talking about containerization tool as a Docker. It could be anything. Okay, it could be, like I said, Rocket containers, LXC containers, and so on. It could be any containerization tool. Kubernetes can maintain containers from any runtime. So whatever be the containers you want to run, whatever containerization tool you want will be running that particular containerization tool like Docker. And then you have Kubelet. What is this Kubelet then? Kubelet is nothing but a component again which runs on every worker node. Okay, Kubelet is the main component, okay, which will interact with the control plane and start deploying the containers. Means control plane, like I said, the master or the control plane of the entire cluster is the decision maker. Means this will tell each node, okay, when to start a container, where to start a container, and so on. All of those instructions will be given to this Kubelet. Kubelet is the one which performs all these tasks. So Kubelet, we can say it's a Kubernetes agent running on every worker node. Okay, that's the second component. And the next component is Proxy. Proxy is called as network brains of the cluster. Means communication between the containers, communication between containers on different worker nodes. All of them will be taken care by this Proxy. right? Those are the first three components. Everyone clear with these three components? Docker, kubelet, kubeproxy. Everyone understood these three components?
Yes, Preeti.
Right? So then comes the next component called pod. What is a pod? See, you can see containers are inside the pod, right? Why are they inside the pod? Just give me a minute. Yeah. Here you can see, yes, containers are inside the pod. What is this pod? See, in a Kubernetes cluster, you will never see container like this. What is meant by that? See, you will always see container in a Kubernetes cluster wrapped around with a layer called pod. Okay, it is always wrapped around a layer called pod. Pod is a layer which runs around the container. Or else you can say pod is the living environment for the container. Pod is the home for the container, right? So container lives inside the pod. Now whatever you call it, right? So, and also this container will share the pod network. Let's say pod has got some IP address. Okay, the container will share the same pod IP, same pod network. Means let's say the pod IP, this is the pod IP. So container will share the same pod IP with some port number, right? So it's like a living environment for the pod. So always containers lives inside the pod, and pod is the basic and the fundamental unit of deployment in Kubernetes cluster. Means we deploy the pods, we scale the pods, we delete the pods. Okay, you modify the pods. That's how it works. Okay, you never deploy container directly. Means here I mean you never deploy container directly. You don't scale the containers. No, you scale the pods. You scale the pod means let's say you have one pod which runs Nginx container. When you scale it, yes, another pod will be created with another same container or replica, an Nginx container, right? So this is how it works, like a pod where you have the container running in it. So this is how it is working. So now, yeah, pods always runs on the worker nodes. We don't run the containers or pods. Actually, we'll say pods only in a Kubernetes cluster. So we'll never run the pods on the control plane or the master node. Only the work is taken by the worker nodes in the Kubernetes cluster by default. But if you want to put the containers on master also, you can do that. But that's a general architecture and that's a best practice. We don't put load on master. Master is a dedicated server which will take care of the entire cluster. Right? So, yeah, Docker, Kubelet, kubeproxy, and pod. Okay, let me ask you one question. Okay, fine, containers are wrapped around a layer called pod. Just imagine it's like a wrapper around the pod, around the container. So, okay, what is the importance of this pod layer? Does it have got any importance? Why is it wrapped with a layer called pod? Has it got any importance?
Maybe to keep containers that are together, like similar containers together.
Yeah, see, you can have pod with one single container. That's a general practice, one container per pod. But you can also have multiple containers inside the pod. They are not replicas, okay? Different container. Maybe this is the, let's say, the containers. There could be other containers, okay, like this. Because there might be a main container, let's say, which is web server container. And to provide always files to this container, there might be a sidecar container. Okay, we'll discuss that later. In that way, you can have multiple containers in the pod, a helping container kind of. But generally, one container per pod. So, what is the importance of this layer? See, this layer, the importance of this pod layer is layer of abstraction. It's a layer of abstraction. This pod layer is called a layer of abstraction. So what is meant by this layer of abstraction? See, like we discussed, you may be running any kind of pods here. Okay, you may be running Docker containers, you may be running Rocket containers, you may be running containers from any runtime. Okay, irrespective of the container runtime, Kubernetes manages them in the same way. Means it just deals with the pod. Inside the pod, the container environment, the container runtime means you might be having containers from any runtime. Still, the way it works remains same. That is the importance of this pod layer. Pod layer is a layer of abstraction. Got it, everyone? Understood? So that's
Preeti, does this pods will have like different IP addresses? Like every pod will have different IP, or
yes,
does
every
they share?
pod will be. Yeah, every pod will be assigned with some IP address. Like here I have shown you, every pod will be assigned with some IP address to access the container inside pod and some port number. Another container, if you have in the same pod IP with a different port number. Pod IP will be same. Every pod will be assigned with some IP. Got it?
Yes, ma'am. Only port number changes.
Each
Only port number will change.
Yeah, each container can be accessed on a different port number.
Okay.
So these are the components which runs on every worker node. Okay, how to install, how to set up, all that comes under cluster configuration. We'll look into that later. So yeah, every worker node will have these components. Then comes the master node. Okay, this is the control plane of the master node. Okay, control plane has got again different components like API server, scheduler, controller manager, and etcd. It has got again 4 components. Okay, the API server, scheduler, controller manager, and etcd. So what are these components? What each component does? Let's see. See, API server is called the master component, or the main component, or the core component, whatever you call. That's a first main major component. That's also called as brain of the cluster. Okay. And what it does, see, generally we give instructions to the Kubernetes. Generally, how do you give instructions in Kubernetes? Kubernetes prefers declarative approach. Kubernetes prefers declarative approach. Declarative approach meaning you define your deployments, you define your pods or containers in a manifest file. Okay, this manifest file is written in YAML. This can be written in YAML or can be written in JSON. Majority of the times we use YAML, so we'll be creating those manifest files in YAML. Okay, you create a manifest file, you run the manifest file, then you create your containers. That's how it happens. You can also use imperative approach. Imperative approach means like you do Docker run create from a single line commands from your command line. That way also you can do that you can do if you want to do configurations very quickly and all. But Kubernetes prefers declarative approach. Okay, but for certification purpose, like if you want to take up any certifications, then yes, this one you should learn, imperative approach. That's a whole kind of different learning. If you want to take up certifications in Kubernetes, then you have to go for imperative approach, but real practice will be using declarative approach. What is actual difference? I'll show you. So yeah, whatever it is. So you give some instructions, or you define your cluster in a manifest file and run the manifest file. When you run the manifest file, what happens? It is fed to the API server, means it's given as input to the API server. Okay, through command line. Kubernetes has got command line. It has also got GUI, user interface. It has got Kubernetes runs on like you have got a GUI which runs on the browser, from where you can also do deployments. But this is not much widely used. Most of the time we need CLI for Kubernetes. Okay, so yeah, whatever it is, whether it is from GUI or whether it is from CLI, you give some instructions, whether in declarative approach or imperative approach, means those instructions or those manifest files are fed to the brain of the control plane, which is called API server. Okay, API server validates them. API server validates them. API server understands the request, okay, given. API server will validate them, understand the request, and API server will apply them, right? Means, see, API server understands, okay, in the manifest file you have written, okay, we need to deploy 4 containers. API server will check, okay, it should have 4 containers, and it will send the instruction to the kubelet running on every worker node. That's what we discussed. Kubelet is the one with which receives instructions from the master. So API server will send instructions to the kubelet on every node as per the manifest file after validating it, after understanding the requirement. Okay, but before it sends to the kubelet, what it does actually, there is another component called scheduler. Okay, it will send request to the scheduler. Scheduler, as the name says, will schedule the pods. Okay, it will decide whether a pod should be started on worker node or whether a pod should be started on worker 2, at what time a pod should be started on what node. All of this kind of scheduling will be done by this scheduler, isn't it? See, on worker node, okay, there are enough resources, but there should be a pod started, right? So this kind of scheduling will be done by the scheduler component, right? Then what is controller manager? Means before it sends instructions to kubelet, it interacts with all these components. Okay, scheduler will then interact with the controller manager. What is a controller manager? Controller manager is nothing but it is like it performs some health checks on the cluster. It performs some health checks. It also performs like whether whether the deployments were as per the manifest file or not. Means it will check the desired state of the cluster across the actual state of the cluster. What is meant by that? Okay, desired state means what you define through your commands. Let's say in the manifest file or through the command I have instructed 4 containers. So actually whether there are 4 or not in the cluster. Let's say there are only 3. Okay, so it keep on doing this check. That's called, it performs some health check on the cluster. Also it performs unending, means non-terminating. Unending or non-terminating, whatever you call it, will always perform some unending non-terminating loops to check whether the actual state, whether the actual state is as per the desired state that is defined in the manifest or not. It will be running some watch loops which are unending, which are non-terminating. It just keep on watching the cluster. Okay, if it is not as per the desired state, what it does, it will again inform the scheduler. The scheduler will then start a pod, right? So scheduler will decide, okay, pod should be started now in 10 minutes in a worker node or worker 2. So this kind of scheduling will be done as per that. Understood the 3 components: API server, scheduler, controller manager. Is this clear, everyone?
Madam, can you say about controller manager? Like unending, non-terminating. I haven't understood that.
Unending non-terminating means it will watch continuously. Okay, it will keep on watching continuously 24/7. It's like a watchdog for the cluster. Non-terminating means there is no stop for watching. There is no end for watching. It runs continuous watch loops so that it verifies actual state is as per the defined state or not. Am I clear?
Yeah, okay,
Means
madam.
until schedule time, or is there any time for that? I mean, to watch those loops?
Continuously, that's what is continuous. Continuously, it's keep on watching. It will continuously monitor the cluster. Monitoring is a
Okay.
different term. We should not say monitoring here. It will check the health of the cluster.
Until the, I mean, deployment, I mean, scheduling.
Continuously it will
Okay.
do this watch. That's what is unending. There is no end. There is no stop.
Okay.
It will continuously keep on watching this. It's like a health check. It performs the health check of the cluster. Okay, it performs the health of the nodes. It performs the health of the containers. Always it performs these checks. And as per the checks, if the actual state is not as per the desired state, it will send instructions to the scheduler. Scheduler will check the resource availability, will check the number of containers available, and it will send instructions to start a pod on a particular node. So that's what API server, scheduler, controller, manager will do. Means before sending instructions to the kubelet, this is what means. This is how these components interact. Now, what is HCD? HCD is called as memory of the cluster. If you call API server as brain, HCD is called memory. Means it has got all the information of the cluster stored. Okay, like how many containers are there at present, what are the resource availability of on each worker node, okay, how much of resources these are, everything, all the information, what is the previous deployment, how many containers were deployed earlier, all of this kind of information will be stored in HCD, which is called memory of the cluster. And I told you, okay, scheduler is scheduling the pods, but how does scheduler get the information of how much resources are available or not? That's what it gets the information from HCD. It connects to HCD to get the information of availability of resources. Accordingly, it will schedule the pods. Right? So it will have all the information. HCD is very important. And this HCD here, all the information is stored in the form of key valued pairs. Okay, key valued pairs means like X assigned with some value. A key, X is key assigned with some value. So it's not a SQL database. It's called NoSQL database. Here data is stored in the form of key valued pairs. So this is how these components interact before it sends instructions to kubelet to make the containers. I mean to deploy the containers, to run the containers. Scheduler will schedule them, but how does scheduler know where to schedule? It gets the information HCD, like availability of resources, how many are available, earlier kind of information. Controller manager will always perform health checks. If any deviation is there in the actual state as per the desired state, it sends instructions to the API server.